So one thing I was looking for at J5 Create and everywhere else on the show floor is 10 gigabit USB-C to 10 gigabit Ethernet. Is that a thing that exists? J5 Create does have a 10 gigabit to 5 gigabit Ethernet adapter, so I guess the USB overhead won't give you any kind of a penalty. You should be able to get the raw speed, but really mostly they were just showing off their 10 gigabit USB Type-C docks and multiple 4K display outputs and a lot of really cool USB stuff, USB accessories, but I want a USB-C 10 gigabit to 10 gigabit Ethernet adapter. Does anybody over on this side have a 10 gigabit USB-C to 10 gigabit Ethernet adapter? And the answer is no. Waterproof power delivery systems and distribution systems. So much stuff. We literally have video products from Yuan, and they can do 8K 60 capture, but 10 gigabit Ethernet, no. Why is USB so cursed? MSI is doing the smart charger thing too. Everybody's getting in on EVs and power distribution systems and all the upgrades that go with that. Also found some absurdly huge e-ink displays. I really can't wait for those to be affordable enough and available enough that I can just deploy these in my house. Player 3 has entered the game. The Ampere 1 processors, dual processor in this 1U chassis from Gigabyte. You know, you've got 8 memory channels, 2 1 gigabit LAN ports built in, 12 Gen 2.5 inch Gen 4 NVMe SATA hot swap bays, dual ROM architecture, OCP 3.0, Gen 5 x16 slots, dual 2000 watt power supplies. So ARM is already ready for the prime time. This is a normal 1U server ready to drop into the data center. Maybe you need a little bit more expandability. 2U is an option, which gives you more PCIe connectivity. You get the same OCP3 slots at the back, the same memory configuration. I mean, this could potentially be a really insane memory density, Ampere 1, and it's basically ready to go. Dual 5 nanometer process technology, ARM CPUs, ready to go here today. ARM's a threat. And or congratulations, ARM, depending on your perspective.
I'm in danger.
Maybe one CPU is a little bit more your speed. Well, you can get an ARM system with a single CPU, but you've still got up to 128 cores, 256 cores if you've got dual socket, but you know, 128 cores, yeah, that's fine. 2 full height half-length PCIe Gen 5 x16 expansion slots. And kind of a lot of power distribution in case you need to run something that uses a lot of power. Dual 1300 watt 80 plus platinum redundant power supplies. Again, this is a standard rack configuration ready to drop into the data center, but it's ARM and it's ready to run your Linux or open source workloads, or really actually a bunch of workloads even beyond that. But it's basically ready to plug in and deploy in the data center. Cost per watt, cost per unit compute, cost per other thing is going to be the dominator in that conversation. EDSFF in the server, in the wild, yeah. So storage we were taking a look at earlier, like from Kioxia in this form factor, in 1U. Look how much storage you can pack in a 1U server in the EDSF form factor. This is really a lot of fun. And all of these connections at the rear, they're all PCIe, and you've got to have this kind of a setup to use it. This one is based on 4th Gen Xeon Scalable in this 1U platform. That's what we need in terms of PCIe connectivity. Now normally there's a G-RAID card back there to do the software RAID, or the hardware accelerated software RAID through the PCIe connections, but it's a lot of connectivity needed for that many NVMe drives. Well, that many EDSFF drives, which are PCIe connected, so still kind of PCIe storage. Think about the possible storage in 1U of insanely high-speed storage. 32 drives, times 15, 16 terabytes of capacity. The editor's going to do the math for us. Look at that number. That is an absurdly huge number. So if you're going to have a number that large, you're going to need insanely fast connectivity, right? Well, what about the Mellanox Computex 7? General purpose short depth or medium depth?
Yeah, I would say medium, but I would say this short depth.
This is single socket, 4th generation, so Sapphire Rapids. This chassis supports up to 4 full height, full length PCIe slots. Plus we've got extra PCIe connectivity on both sides here. There's lots of room for PCIe connectivity, and you've still got room for storage. There's also the E263Z30. Now this is a short depth server, but check it out. You get 2 full length PCIe Gen 5 slots in the top there, and then you got 4 more half length, full height PCIe slots there, and it's PCIe Gen 5. You've got Sapphire Rapids on top of that, so you can run this as your Sapphire Rapids platform, the full 8 memory channels, and still have a lot of room for everything else you need to do, and the storage is at the rear for your operating system. Plenty of cooling for whatever you're going to be running for your PCIe peripherals. This is the Inference Specialist. Inference with machine learning. Yeah, check it out. The AMD inferencing cards. These are only 8 PCIe lanes, so they can pack 4 of them in here in this chassis design. Normally, something like this chassis would be used for, a double height GPU, but in this case, these inference cards don't need it. They still give you the same level of compute, but they're a lot more compact. So they can fit 8 of those in a side, 16 per chassis. If density is the name of the game, then this system is 4 2U nodes in a 2U chassis. And this is Genoa. So this is the newer version of the chassis that I've taken a look at before on the channel, except you're supporting up to 96 cores per socket, 2 sockets per system, 4 systems per node. And you've got all that NVMe connectivity at the front of the chassis. 6 connections per node. And this is what Jensen was showing us on stage. This platform, most powerful AI supercomputer, the world's first Nvidia certified HGX 100, 8 GPUs in 5U. So this is, again, ready to deploy in your existing rack. These are your 8 GPUs on the bottom, and this takes up just 4U of rack space. The 5th U is this 1U dual socket node on the top. This is where your compute's going to live, and you got all that high-speed connectivity to your GPUs that live in the bottom. Grace, it's the CPU. Hopper, it's the GPU on one module. And then wait a minute, should there be another module over here? Yes, very good, very astute observation. But wait, this chassis will actually support 4 of these? Yeah, well the heatsink is missing. There should be a heatsink here because it's going to need a lot of airflow, it's going to generate a lot of heat. This thing has up to 96 gigabytes of GPU HBM3 memory, 512 gigabytes of LPDDR5X with ECC CPU memory capacity. It's a 2U 4-node design. This is CPU plus GPU designed for giant scale, high performance AI plus compute. It's got triple 3,000 watt power supplies because that's the kind of power load we're up against when we're cramming all of this in 2U. But this is basically standard rack configuration. It doesn't require anything exotic. You just plug it in, and then you're good to go on whatever your existing networking infrastructure is. With Nvidia getting into the CPU game a little bit more formally, I guess, this system will give you 2 CPUs per node from Nvidia. I mean, yeah, 2 high-performance CPUs for high-performance compute and cloud computing, but you still have 4 nodes per chassis. This is the Grace CPU Superchip. It's designed with up to 144 ARM Neoverse V2 cores, and that's got SVE2, 900 gigabytes per second NVLink C2C connection. That's about 7x faster than PCIe Gen 5, if that gives you any idea. Up to 1 terabyte per second of total memory bandwidth, and up to 960 gigabytes of memory capacity per module. And yeah, it is compatible with Nvidia Bluefield and Bluefield 3 DPUs. You've also got 16 dedicated NVMe slots at the front. The Nvidia ConnectX 7 for ultra high-speed connectivity for whatever you happen to plug in. Nvidia doesn't care. It's PCIe. You can use that on your EPYC system. You can use that on your Sapphire Rapids system. You can use that on your new Grace Hopper supercomputer system. That's no problem at all. But what if you could get that kind of a physical interface, but in a Bluefield DPU? This kind of thing is really exciting because it lets you move a lot of your software stack onto a PCIe card potentially, which will take some of the load off of your server. What that means as a practical matter is if, for example, ZFS you're using it for storage, you could actually do ZFS processing directly on this card and then write the process data to system memory or other PCIe devices in the system. So you could do direct PCIe to PCIe I/O. The hardware exists, and for some customers, they have the software and they're doing special stuff in order to really take advantage of this. But this is basically a full system on a card. We've even got a teeny tiny CMOS battery located right there. I mean, this is, for all intents and purposes, this thing is doing compute and it is networked with the host system, but via PCIe. Patriot was also here showing off their Gen 5 SSDs. 12.4 gigabytes per second read and 11.8 gigabytes per second write. It's not quite enterprise storage, but it is PCI Express Gen 5. They're also showing off their fast DDR5 memory, flagship 8,000 mega transfer per second memory. They may have made a mistake on their sign.
I actually mentioned that, yes. Oh, I'm sorry. Oh my God, you're recording. Hi. I promise I'm a good guy.
It's fine.
I know the difference between mega transfer per second. That's actually 4,000. It was a misprint.
Oh, okay.
It's 4,000 megahertz / 8,000 mega transfers.
We should put a post-it note over it. So we were looking at enterprise storage earlier, and I was just commenting, it's like PCIe Gen 5 storage is already here in consumer land, basically. Even though all those servers with all those E1.S drives, nobody's got PCIe Gen 5 storage yet in those.
I might have something for you to look at. Right? These seem like something, why would you make a crazy high-end kit? Very few people can run it. This is to show, this is that old adage. Like, why do you do this? Because we can.
Yeah.
If we can build this, we sure can figure out, how to make the more basic gaming kits. Like, for example, these are the new guys. We did show like a preview at CES, but they come in white as well. So if you don't like the Viper Venom styling, which comes in RGB, non-RGB, these come in RGB and non-RGB with white, and they go up to 7,000. Or AMD Expo up to 6,200. The 7800 has 7600 and 7400, and the 7600 has 7400 and 7200.
That's a nice feature. I don't know why anybody doesn't do that.
We do it just so that more compatibility. It gives people peace of mind. Because let's say you think, hey, my board can support it, but your chip's not that good. Now you don't have to be like, oh, this isn't good for me. You just select the other profile.
Makes sense. I'm over on the other side now, and found some more USB system, USB peripheral vendors, I guess, chipset folks. 5 gigabit Ethernet, eminently doable. 10 gigabit, not so much. Maybe ASMedia won't let me down. 240 watt USB charging, no 10 gigabit Ethernet. This kiosk accepts a question and then answers it with AI. And it's not even an Nvidia demo. Literally, ChatGPT.
I'm processing your request with the most suitable response. Please give me a moment.
That's so cool!
Huh? It's magnet. We just it's a magnet inside, and with a copper core.
Yeah.
And the power on and the floating light. And we just show our mouse.
We have that, but we don't have 10 gigabit Ethernet in a USB-C form factor. What kind of clown world is this? PCI Express serial cards? Oh yeah. But no 10 gigabit Ethernet.